So relationships and heuristics is basically in a little bit of like you have this essentially situation where you have a description of the problem and you have to write software. So you have to make some decisions early and some decisions later, and there's the entire process, right? So this process involves your own methodology, right? So this is what heuristics indicates. It's basically trial and error experimentation. It's basically, and plus I would add to this also an experience, because if you have already solved similar problems, you already can predict the entire process, right? If you don't have a lot of experience in there, then there will be much more of a trial and error in the in your own way of solving that problem, right? You want to use some sort of best practice. You want to rely on something as you proceed. So the best practice sort of solutions, which are largely suggested by some prepackaged design patterns of class relationships and possible solutions, are basically themselves have building blocks, and these building blocks essentially based on certain idioms or solutions. So more formally, basically rephrasing what we had on this slide and moving forward with this set of ideas, you can say that you can say it more formally in more programmer friendly language, is that you can say that object A is a logical or physical part of B. A logical would likely indicate an aggregation, and physical would indicate a composition. A is logically, physically contained. Okay, so I kind of like separate this for this would be more for indication of aggregation relationship. This would be more of an indicator of actually a true composition, the physical containment. Knowledge awareness is simply an association, so that A has a knowledge of B with the persistence beyond a single encounter, right? So a single encounter would be just a method call, right? So we have one object which makes a method call, and perhaps a parameter to that method call may be a reference to another object. So this is a single encounter which is insignificant in terms of overall structure of an application. However, if A has persistent awareness of B, that means that we have an association, right? So like, for instance, we can try to think about it as, for example, so we can have the owner and property, right? So we have the property which is owned by someone, and so clearly this is very likely to be just an association like this, right? And even we don't even have to indicate the arrow here. Oftentimes when things happen, you can just say you can simply say that there is an association, and it's just a single line like this without arrowheads. You can have property which references the owner. You can have the owner who is referencing the property, and you may not even know exactly to begin with. When you just start working on this, you may just use a single line to make this connection and indicate that these objects are aware and have knowledge of one another, right? So that would be this knowledge awareness type of building block for your solution, but this is important knowledge. A is a member of B, another indicator very similar to the previous one. A communicates with B on a regular basis. well, if you need this type of communication on a regular basis there, right? It sounds like we should have an association so that we don't have some kind of like third party which constantly provides this reference to this object. That may not need to make sense anymore, right? That's unnecessary. You just create basically create a direct association, and that would be totally unnecessary. So I don't know what my software does here, but it just like takes liberty to remove boxes from my drawings. Anyway, but these are good indicators of, you know, relationships that should exist in the structure of our software, and of course materialize in form of a relationship between objects. A owns or manages B, right? Another management is simply just a different type of communication, right? So many of these things kind of overlap in what they really indicate, but these are interesting aspects to pay attention to, I guess, when we go through the design stages. So association is just a single line. Interface and controller, this is more from a hardware world, right? And the associations can be named. Okay, so person and property here, very similar. With respect to perhaps person and property, person owns a property. So we can indicate that this association over here indicates the ownership, that the person owns the property. But we can also do it the other way. We can say property is owned by the person, but there's also there could be just an occupancy, right? There could be, as opposed to ownership, there could be a tenant or someone renting this property, so that we can say that it's occupied and there's a certain occupant, and that occupant is this specific person, right? So relationships and associations can be named in UML to explain better what type of relationship is taking place between those two. So this is really, in software, this will look exactly the same, right? This object will just basically have a reference to another object. However, logically, we can, and we have an ability to, in UML, to specify the type of relationship. Continuously, basically, we can have these relationship names used as roles. For instance, this is somewhat confusing. It's basically that we have an employee, and we can have a set of employees simply by giving the employee a reference to another employee. And if that's happening, then the role of this association of employee with itself would be the set lead and set member, and that creates a list, right? So this is somewhat confusing, but basically, instead of indicating that you have this employee, actually, we can actually use this, instead of using the employee, we can actually try using the owner, right? It's interesting that property could have multiple owners, right? Or the owner could have multiple properties, right? So this same owner could own different properties. So how do you do this, right? I already told you that informally, when I think about of my own designs, I sometimes do this, but this is not legal UML. It's just my own sort of like index card depiction of the fact that there may be multiple, like stack of index cards of these objects associated with the same owner. However, I want to sort of like undo this. I want to undo this and remove it so that instead, the way I can design it is that property class over here can have an attribute can have an attribute that points to another property, right? Points to another property. Basically an attribute over here, which points to another property. So it would almost be like an attempt to essentially clone this, right? Take this, Control C, Control V in my world here, right? Clone it, and then essentially say that, hey, this property can be pointing to another property, which in its own term can point to another property, and so forth, right? So in UML, it's not allowed to duplicate the same class in UML notation. Instead, what you do is you say, if that's the case, if property can be pointing to another property, you just simply what you do, you simply essentially create an association with itself, okay? And you just basically say, look, the property, and this way you don't even have to indicate that there is a reference to itself, because it shows by this arrow that shows a connection with itself. It basically says, hey, there is a reference to another property inside this property object, and therefore, if that's the case, one object can reference another, and you have a list of objects this way. So usually when you see in your UML diagram a box like this, right? A box like this over here, right? Which has connection with itself, it is simply an indicator of a collection, right? That essentially it just indicates that that the owner can be connecting itself with the lead or head of the list, but then this initial element on that list may have reference to another one, which can have reference to another one, So, in real computer memory, what you're going to end up with, you are going to have basically set of objects which basically reference and keep referencing one another, right? But this is how UML depict with this. Of course, the last one, most likely it will have a reference that is set to null. And, over here we can indicate, a null pointer with an X in it like this, right? So that is common to see on UML in terms of collections. Right. All right. So let's pause our recording and move to the second room, and we will continue with this presentation.